Hello and welcome to Day 2 of MD&DI's Focus on Fundamentals course, Medical Device Testing, Regulatory Updates, Trends and Changes, including FDA, ISO, and MDR, sponsored by Nelson Laboratories. I'm Chris Keach and I'll be your moderator today. We have just a few brief announcements before we begin. First, this webinar is designed to be interactive. The dock of widgets at the bottom of your screen will allow you to learn about today's speakers, download resources, share this webinar via social media outlets, and participate in our Q&A session that takes place at the end of our presentation. Please note that we will try to get to as many questions as we can during our Q&A, but if we do not get to your question today, someone will get back to you after the program is over. Also, the slides will advance automatically throughout the event, and you may also download a copy of the slides via the Resources widget. Towards the end of our webinar, we will ask you to complete our survey found on the right-hand side of your screen. Please take a moment to fill this out before leaving us today, as your feedback will provide us with valuable information on how we can improve future events. And lastly, if you're experiencing any technical problems, please click on the Help widget found at the bottom of your screen or type your issue into the Q&A text area, and we will be glad to offer one-on-one assistance. And now on to today's class, Navigating Packaging Changes in Light of New Regulatory Requirements. Discussing today's topic from Nelson Laboratories is Wendy Mock, Consulting Manager, and Jennifer Giggy, Packaging Department Scientist. To learn more about our speakers, please visit the Bios widget. It's with great pleasure I now turn this special session over to Wendy to begin. Wendy, take it away.
Thank you, Chris, and thank you everyone for joining us today. The agenda that we're going to cover includes what are the applicable standards, and then we're going to take a deep dive into some of the updates and the changes that were implemented to these standards. We're going to address everybody's favorite topic, sample size assessments, and then we're going to talk about a few tests that will bring you into compliance for these recognized standards. So let's get started because we have a lot of stuff to cover. This slide is a summation of all the current standards that are applicable to the packaging industry. We have our GMP 21 CFR. Our device packaging is called out that each manufacturer shall ensure that the device packaging and shipping is designed and constructed to protect the device. The overarching AAMI ISO document is outlined in 11607, which has currently revised in the EU and is in process of approving in the US. There are two parts to this document. Part one is for the medical device manufacturers that identifies the requirements for the materials of the sterile barrier systems and the packaging process. Part two is the validation requirements for forming and sealing. The next document that we have is ISO 16775. This is currently being revised. It is a guidance document for the ISO 11607. And it has a lot of great information on how to meet the requirements. The last document in the list is the EN 868. Part 1 is harmonized with the 11607 document. Part 2 through 10 have a specific information regarding the different material combinations. For example, if you're looking specifically at Part 2, you would be a manufacturer using sterilization wrap, whereas if you were looking at Part 5, this is applicable for sealable pouches. Okay, let's talk about the changes of the MDR and its impact on packaging. Why does it matter what happened with the changes? As many people already know, and I mentioned earlier, ISO 11607 was revised, and these revisions were made to specifically support compliance with the new directive. The implementation date for these new regulations is May 2020. This is important because there is no grandfathering clause. All medical devices that are packaged and manufactured will need to be in compliance effective May 2020. The next thing that's really important about this is there were a couple of key words added that show increased awareness from qualified notified bodies to be inclusive of packaging processes when auditing. For example, the definition of a medical device has been updated that products specifically intended for cleaning, disinfection, or sterilization shall be deemed to be considered a medical device. This includes accessories such as packaging materials. Medical device packaging is the accessory and therefore is governed by the MDRs. That's why the 11607 was updated and brings it into alignment, and these definitions are now concurrent with ISO 11139. So I'm going to pick a couple highlights that are specific to the packaging industry. So the first one was specifically outlined that devices and manufacturing processes should be designed to eliminate or reduce the risk of infection to the patient, and the design should allow for easy handling and minimize contamination. What does that mean to you? So with the introduction of usability evaluations, ISO 11607 wants you to assess the ability of aseptic techniques in the intended clinical environment. How is that package opened, and is it opened as its intended use? The usability evaluation will meet the requirement for the packaging function of the MDRs. You do that using a documented evaluation demonstrating the contents can be removed aseptically. Furthermore, a package serves as a means of dispensing the product. So how do I go about doing that? You need to ensure that your design allows for easy and safe handling while minimizing microbial contamination. You also need to look at the integrity of the packaging. Is it evident? Do you have a tamper evidence seal? And then is it correctly identified? Is the labeling correct? These studies will allow you to mitigate any risks with the correct use of the package while leading to higher understanding of the factors that control the quality of the user's interactions with your product. These usability studies are not new to medical devices and have actually been around as part of human factor engineering. They're just new to the evaluation of the actual packaging process. So taking a look at objective evidence behind these testing is how you're going to identify that you've met the requirements. So how do I go about demonstrating usability studies? One of the ways you can do this is by including evaluation of your interactive characteristics. Are they perceived as usable and appealing, and do they enable safe and effective interactions? Additionally, you can do this by measuring objective through performance. Interviews, one-on-one, group settings, or contextual inquiries. Contextual inquiries can be conducted to understand the needs of the market and to scope the opportunities. By watching the user in the course of normal activities and discussing those activities, you can demonstrate and document that you have performed usability studies. The second highlight that I'd like to look at is specific to ensuring that the integrity of the packaging is clearly evident to the final user. 11607 incorporated a best practice visual inspection and that the integrity of the packaging is clearly evident to the end user. What they're looking for here is instructions for what happens if the packaging is damaged or unintentionally opened. Does your label refer to your IFU and state that if the barrier is breached, the product is not usable? Those are the kinds of things that they're looking for. Additionally, validation reports, including packaging, needs to be included with your technical documentation that is being reviewed by notified bodies. no longer acceptable to just state that your packaging is validated. They're going to be taking a look at those final reports and doing a thorough review of everything that's captured as part of that. Annex N of ISO 16775, which is an informative annex, provides examples of attributes that can be evaluated prior to opening by the end user to ensure that your integrity packaging is evident. Okay, highlight number 3. The need for revalidation should be addressed and recorded. Previously, revalidation wasn't very well addressed in the ISO 11607. In fact, it was only identified in 16775. However, with the revision, this has now been brought into the document. It's important that you take a look at changes over time, and those can be anything from the sterile barrier system, if you do an equipment change, are you changing the device, or maybe even looking at different sterilization methods in light of recent events. This could be something that people are considering. One thing that we always like to point out is that it's when this engineer does a change, for example, they're changing their dye from this color to that color, and then another engineer is doing a product improvement, a lot of times different areas aren't working with each other, and so the changes can go unevaluated as a whole. So it's important to make sure that you come together and take a look at all of the changes that are done as part of the entire packaging and product system. Some changes can be minor that revalidation is not required, but then the cumulative effect of all of these changes could require additional testing. This justification should be documented possibly on an annual point, but definitely needs to take place and gives you a really good view when the FDA comes to take a look at your information. Some additional changes that I want to point out to the ISO 11607 is that revalidation requirements to material design and sterilization should be evaluated. There is also an update to the test method conformity list. This includes now the declaration of precision and bias statements and the inclusion of many more options to meet those requirements. Additionally, there's a discussion on differentiating different packaging levels. This is just a discussion. There is no requirements or recommendations outlined. It has not been finalized. What the driving force here is behind identifying specifically what the location of the SBS barrier is. This is most important when you're looking at double pouch or double tray systems. Is the outer the sterile barrier or is the inner? So this new labeling approach is very important to be considered and discussed and taken advantage of in the future. It's also important that anything that compromises the original validation parameters or the integrity of the sterile barrier system or SBS, that is what drives whether your revalidation requirements are needed. Okay, let's talk a little bit about sample size assessment. ISO 11607 states specifically that sampling plan shall be based upon a statistically valid rationale. These results are set by acceptable confidence and reliability levels. At Nelson, we follow a patient risk evaluation in combination with RPN or risk priority numbers, and then we tie that into confidence and reliability rationale intervals. ISO 2859-1 is an example of a document that you can refer to for inspection by attributes in sample sizes. This has some common statistical plans that can be appropriate, especially if you're using attribute testing. Additionally, though, it's important to make sure that the sampling plan that you use is not specifically identified by specific countries or regions. ISO 16775 has a great section on discussing sampling plans. A couple other things you're going to want to think about when you pick the sample size. What is the right sample size? There are many factors that go into picking it besides the statistics. For example, what are the costs? If you have a device that's going to cost $30,000 to develop and manufacture, using a sample size of 29 for every single test isn't going to be appropriate. So you'll need to make sure that as part of your justification, you're also considering the impact to making the product. Now, I'm not saying that because your device is expensive, that means you shouldn't have an appropriate sample size. But what that does mean is that you should consider possibly looking at additional ways of manufacturing that product, possibly using a facsimile or something like that. Additionally, looking at the minimum acceptable level of deviations, i.e. your confidence levels, that's where we incorporate the risk priority numbers. And then finally, what's the output of the data? A lot of times an attribute data can have a lot higher sample size than a variable data. And just because there's even more information around sample sizes, attribute data is going to be a go, no-go. So this is why you're going to drive up the size for the dye migration of bubble. In order to incorporate those confidence levels, you need to have a higher sample size. When you're looking at variable sample size, you're getting a measurement that's specific, and that will usually require less samples. ANSI ASQ has two references that address variable data and attribute data. Okay, I'm going to transition this over to Jennifer. She's going to go through the purpose of packaging, and she's going to take a dive into a few of the tests that show you how to meet the requirements outlined in the 11606.
Thanks, Wendy. So let's talk about the purpose of packaging. The primary purpose is, of course, protection. We generally think of packaging as protection from microbial contamination, but the package needs to be capable of being sterilized, and then it needs to keep what's inside sterile until the point of use. The packaging also serves as protection from the environment. Things like moisture or air could pose a problem for some medical devices and pharmaceuticals. Obviously, you wouldn't want a device with electronic components to get wet, nor would you want an oxygen-sensitive pharmaceutical exposed to ambient air, as that could alter its composition and effectiveness. Packaging also needs to inform. There are lots of rules for labeling, but in a nutshell, the label needs to tell what's inside and traceable information such as lot numbers or other identifiers to tie the device to its manufacturing records. The label also needs to tell if the product is expired and sterilized. And then the packaging also needs to allow for aseptic presentation. You have to get the device out of the packaging without contaminating it, so the device can be used without posing a microbial risk to the patient. Okay, the packaging that's used as a sterile barrier system needs to be validated. So packaging validations are outlined in ISO 11607. Final configuration packaging with product is sterilized. Sometimes people will run 2 sterilization cycles to simulate a worst case. The samples are run through a transportation and a distribution simulation. to evaluate the shipper boxes, and then the product inside would be tested for strength, integrity, and microbial barrier properties. If all these tests pass, then samples are set aside for real-time aging and accelerated aging. When the aging is complete, then the old product is tested again for the strength, integrity, and microbial barrier, and those results would be compared to the new or the baseline results. A package validation is successful if the package passes integrity testing at both baseline and after aging. The strength testing must meet minimum specifications determined by the sponsor, both baseline and after aging. And it's also a nice bonus if the strength values are the same or better after aging. The microbial barrier acceptance criteria will vary by the test that you choose, but you would want to see similar data at both the baseline and after aging. If your microbial test has a pass-fail component, then all the samples would need to pass before and after. If the microbial test generates numerical data, you'd want that number to be the same before and after, and the actual number should be acceptable. The number of samples to test for each physical attribute would be determined by the sponsor using those sample size justification principles that Wendy just talked about. The aging interval is usually the expected shelf life or the use-by date with some intermediate values. For example, if I have a 5-year expected shelf life, I would run testing at baseline and then again at 5 years. But I would also want to include at least one intermediate time point, say a 3-year or a 1-year or maybe both. That way, if there's a failure at 5 years, I can default back to the longest time point that passed, and that becomes a nice little insurance policy. So here is our validation summary. We start with the transportation and distribution testing. Then we will test for strength, integrity, and microbial barrier. There are a number of options in each category. And the right option is usually dependent on a number of factors, maybe the sterilization method and the package type. Some test methods are for the whole package, and some are for the material or the seal only. There's advantages and disadvantages, all the options. And some of it's just preference or matching historical data. For this example, we are going to use a typical Tyvek film pouch. We'll select the seal peel test for our strength, the bubble emission test for our integrity, and the F1608 test for the microbial barrier. So we'll start, as our outline says, with the transportation and the distribution testing. Distribution testing simulates hazards that are typically encountered in a distribution setting. A package will see various temperature and humidity extremes as it's stored and moved in long-haul trailer trucks. Altitude changes as packages are transported in unpressurized aircraft or over mountain passes and put internal stresses on the package seals. Shock or drop events cause damage as packages are impacting on hard surfaces. Vibration over time can create unexpected wear on packages as packages bounce and rub against one another. Device components can loosen with extended vibration, and certain frequencies can cause other internal damage to some components. Compression forces, as packages are stacked in warehouses or on trucks, can cause boxes to fail and collapse. By testing to a controlled and a predetermined amount of stress for typical hazards, we can more accurately predict success in the distribution environment. This uniform approach will not mimic all unusual extremes. For example, there aren't a lot of boxes that stand a chance of being run over by a forklift and coming out unscathed, but if you pass distribution testing, there's a high likelihood that your boxes will get to their final destination with the product inside intact. Let's look at some of these hazards in a little bit more detail. Climactic or environmental stressing mimics the temperature extremes that can be seen by packages as they're transported. Special programmable incubators which can cycle from one extreme to another, are used to condition the packages. There's a pretty long list of options, but the three most common are cold, tropical, and desert. Cold is minus 30 degrees centigrade with uncontrolled humidity. Tropical is 40 degrees centigrade and 90% relative humidity, so that's hot and humid. Desert is 60 C and 15% RH, which is hotter and dry. These would typically be run one after another, and then the box moved to the next hazard category, which is usually drop. The drop hazard is simulated using a special drop tester. There's a movable platen which holds the box until the tester is activated. The platen swings back and the box falls to the floor below. Boxes are dropped on faces, edges, and corners and then evaluated for damage. The drop height is dictated by the distribution cycle and it will vary. ISTA also has a drop-on hazard, so instead of landing on a flat surface, the box lands on a hazard block. Compression is tested with a compression tester. There are two platens which move up and down. A load cell measures the force. The compression value is inputted into the tester, and then the platens will move together until the compression force is reached, or the load suddenly drops, indicating a failure. This would be the apply and release option. The apply and hold option would have the platen hold the value for a longer time. ISTA uses compression under load as part of the vibration test. So a top load would be applied to the box and the vibration test would be run. So you get the effects of compression and vibration together. Vibration can be rotary or random. Rotary vibration is done with a table which runs a 1-inch displacement circle. This is meant to simulate delivery truck or loose load vibration. The speed or frequency of the table varies per test. Random vibration follows a predetermined set of vibration frequencies. These vibration profiles will mimic long-haul trucks on the freeway or airplanes or trains. The vibration frequency profile is specified in the distribution cycle as well. There are two standards groups that write transportation and distribution standards. They are ASTM International. ASTM stands for American Society for Testing and Materials, and ISTA, or ISTA, which stands for International Safe Transit Association. The transportation test procedure is called a distribution cycle. There are a number of cycle options to choose from. Each one is slightly different in the list of hazards they simulate, how those hazards are simulated, and the intensity of challenge for each hazard. The most common distribution cycle is ASTM D4169, distribution cycle 13, and the runners-up would be ISTA 3A, ASTM D7386, and ISTA 2A. Between ASTM and ISTA, there are dozens of test cycle options. So how do you choose which one is best for your package? The distribution cycles are designed to mimic types of package configurations and shipping modes. If you ship single parcel boxes under 150 pounds using truck and air, then ASTM D4169 distribution cycle 13 or ISTA 3A is your best choice. Since that is the most common shipping mode for the medical device and pharma industry, then that distribution cycle is the most common. However, if you ship in a single pallet configuration, there are cycles for that. And if you ship using rail, there's cycles for that. Or if your box is over 150 pounds, then there are cycles for that as well. There are also custom cycles where you can do basically anything. A custom cycle would be helpful if you were trying to investigate a distribution failure or if you want to focus on a single distribution hazard. If you're running an ASTM cycle, you also need to pick an assurance level. There are 3 levels, level 1, level 2, and level 3. They really translate to a low, a medium, and a high intensity. Now, this choice is based on risk. If your product is easily damaged or very expensive, you may choose to test to a higher intensity. That would give you a greater confidence that the product inside will not get damaged. You may also want to test to a higher intensity to see if you can reduce your protective packaging. If you pass the more stringent cycle with less protective packaging, then that also gives you a greater confidence and a greater assurance of success in the field. Distribution, or the assurance level 2, is the most common because everybody just likes the middle ground, but you should be prepared to justify whatever assurance level you choose. So after the distribution testing, we move to the physical properties testing. So let's start with strength testing. If you remember, we chose seal peel testing to demonstrate this property. The seal peel test takes a 1-inch wide coupon from the seal and pulls it apart on a tensile tester, then measures the force required to open that seal. The coupon is placed in the tester grips with the most rigid material in the mobile grip. For our coupon, the Tyvek would be the most rigid. There are 3 test options in ASTM F88, which I'll go over. The most common is the 90-degree unsupported, as you see in the picture here. The tail is allowed to freely move during the pull. This technique gives the most conservative values, so you get the lowest peel results with this method. And this is our default method here at Nelson Labs. The next one is the 90-degree supported. It's very similar, except that the tail is gently held as the sample pulls apart. You have to be careful not to pull the sample as you hold it and keep it at a 90-degree angle so that you don't affect the results. This technique is preferred in the EN 868 standard, and as we're testing for more companies who sell in Europe, we've been doing a lot more of this technique. The 180 supported uses a backing plate to hold the tail. As the sample peels, the plate holds that 180-degree angle. This technique will yield the highest peel values. Now, since results are technique dependent, it's important to use the same technique when comparing results. For example, if your pouch manufacturer gives you a specification and you send samples to a lab for testing and those results don't match, the first thing you want to look for is to make sure that you're using the same testing technique. When too much heat is applied to Tyvek, the material goes from a white to a clear. This is an indication of oversealing. Now, some people think that if some is good, then more must be better. Well, this is definitely not true for heat sealing. When you severely overseal a package, you're melting the Tyvek, and this can create tiny holes in the material that lead to sterile barrier breaches and contamination. If your seals are clear, your sealer is set too high. If your seals are starting to turn gray, then your sealer is probably set too high or might need some maintenance. When the oversealing is less severe, there can be delamination or fiber tear. As you can see in this picture, instead of peeling open cleanly, some of the Tyvek material did not release. Delamination makes aseptic presentation harder. It's difficult to open the package, and the separating fibers could be releasing organisms that might be trapped in those fibers. So the take-home message here is that when sealing, don't go for too cold or too hot. Like Goldilocks, you want to be just right. There are a couple of exciting new things coming from ASTM for peel testing. The seal peel test standard ASTM F88 is revising and will include a new whole tray technique option. This is great news for anyone testing peel strength on trays because you won't be required to cut coupons anymore. Anyone who has cut trays knows that there has to be a better way, and this is coming out very soon. There's also a brand new guidance document that's in the works that should help people in determining appropriate seal strength minimum values. So this is another exciting development that we're watching for. So now we move on to the integrity tests. For this option, we chose the bubble emission test. This is a whole package test which looks at the integrity of the seals in the package. The package is inflated underwater to a set pressure and examined for leaks. A fast, steady stream of bubbles emanating from a single point indicates a leak. The most common problem that we see with bubble testing is caused by folding the seals to stuff the pouch into a shelf box. When Tyvek is folded, it can cause sheet separation. This leads to a channel or a pocket within the sheet. Air will collect in this pocket and then exit from a single point, which looks like a failure. While the barrier may be significantly reduced, there's usually some material left. A dye migration test or perhaps high-powered magnification can be used to confirm whether the bubble test failure is from a channel or from sheet separation. The best practice here would be to use the right size pouch so that you don't have to fold the pouch and avoid this problem altogether. There are some new things on the integrity test horizon. ASTM F2096, which is the bubble test standard, is looking at doing an entirely new round-robin test. This could have all sorts of impact depending on what the results are and how the test is set up. So we'll just have to wait and see what develops there. Also, the visual inspection test standard, ASTM F1886, is under revision. The current version is focused on channels in the seal only, and we expect that the new revision will have some more required defects and probably some clearer definitions. So again, we'll just have to wait and see what happens here. So our last category is microbial barrier. We are using the ASTM F1608 or microbial ranking to demonstrate this property. The F1608 test is for materials only, and it works only on porous materials. A 47 millimeter disc is cut from the material and placed in the test chamber. A spore suspension of Bacillus atrophius is aerosolized and then pulled through the test sample. A 45 micron filter under the test sample collects any organisms that penetrate through the material, and then the filters are enumerated and a log reduction value, or LRV, is calculated. The higher the LRV, the better the barrier. LRV values can range from 0, which is no barrier at all, to a 6, which means basically nothing got through. There's no standard acceptance criteria for the LRV value. The type of material, medical grade paper versus Tyvek, will affect the LRV, and the thickness of the material and any applied coatings will also affect the LRV value. Lastly, let's talk for a moment about aging. Real-time aging is required at normal storage conditions. Packages would be stored for the expected shelf life or use by date. Then they would be tested for strength, integrity, and microbial barrier properties. Since real-time aging for 5 years takes 5 whole years to do, accelerated aging is usually done as well so that data can be generated faster. A 5-year accelerated aging takes less than a year to do, which is much better if you're trying to get a product to market. There's some special considerations to remember, though, about accelerated aging. Accelerated aging is based on the theories of Arrhenius. Essentially, as the temperature increases, the reaction rate increases. The higher the temperature, the faster the aging happens. However, as you increase temperature to save time, you do other damage to the product and packaging materials. Now, some materials can tolerate more heat and some just can't. So it's very important to understand your materials before selecting your aging temperature. It's also crucial to remember that accelerated aging does not replace real-time aging. The real-time aging is required. Accelerated aging is optional. The real-time should be started at the same time as the accelerated aging, and expect to be asked to prove that it's underway when you submit your accelerated data. Now, accelerated aging is different from environmental stressing that we do as part of distribution testing because the samples are held at a high temperature for a long period of time. The environmental stressing from distribution testing is looking at short-term temperature extremes, say 1 day to 3 days. and it usually involves moving from one extreme to another, like very cold to very hot. Accelerated aging is holding a product at an elevated temperature, the same elevated temperature, for a long period of maybe 6 weeks to 30 weeks. Aging is usually done with the final product. The first step is to determine your storage temperature. The FDA prefers 25 degrees C, so that's what we recommend. Next, you determine your aging temperature and humidity. The most common temperature is 55 C and 50% relative humidity. But remember to stay at least 10 to 15 degrees below the glass transition point of your materials, and so that's why it's important to understand your materials. The ASTM F1980 standard that governs accelerated aging is up for revision. They are looking at the effects of moisture on materials. Some materials will absorb moisture and some do not. Some failures after accelerated aging may not be real, especially when those failures are not duplicated after real-time aging. This might lead to some recommendations on humidity levels or some other things there. We're just going to have to wait and see. All right, Wendy, it's back to you to finish things up.
Thanks, Jen, for that thorough review of the applicable test methods. I'm going to quickly summarize what we spoke about today. As you've seen, the MDR changes in the EU were driving the packaging updates, including a new focus on the prevention of microbial ingress. It's not something at this point now that you can just say that you have done, but it is something that you have to prove that you have done. Even though the standard does reference a correlation to physical testing, a majority of clients are not providing that correlation, and it is a lot easier to just do the testing and a lot cheaper. Usability studies are becoming a focus, even though there aren't any instructions on how to move forward with doing that. An evaluation of these studies, looking at how they present, how they're opened. Did you design your packaging to be easily accessible yet still maintain that aseptic presence? And then revalidation was the third item that is a key component. Any changes in your SBS, your equipment, your processes, etc., you must consider and evaluate if any additional testing is needed. The question to always ask when you're looking at that is, did this change impact the completed validation testing you have on file? If it does, then it is very likely that testing will be required. So Jen went through the packaging validations and how to meet the requirements outlined. These included an evaluation of at least 3 specific properties, including the strength, integrity, and the microbial barrier, and ensuring that these properties are demonstrated not only in the initial, but also throughout the establishment of that use by date. And then finally, we did a focus on test sample size and ensuring that it is established using a statistical valid rationale. We were able to provide you with a couple of options that will show you how to do that and how to go about documenting everything. I believe that wraps up this webinar, and we can now turn the time back over to Chris.
All right, well, thank you, Wendy and Jennifer, for a fantastic presentation. Now, before we begin with today's Q&A, please direct your attention to our webinar survey available on the right-hand side of the presentation window. If you close the survey, you can reopen the widget by clicking on the icon along the bottom of your screen. Thank you in advance for filling out the feedback form. Your participation in this survey allows us to better serve you. We're going to now move on to the question and answer portion of our event. As a reminder, to participate in our Q&A session, just type your question into the text box located to the right of the presentation window, or click on the Q&A icon at the bottom of your screen. And please note that we're going to try to get to as many questions as we can in the time that we have left. If we're unable to get to your individual question today, someone will get back to you after the program is over. And as a side note, don't forget to tune in tomorrow for segment 3, or the third installment in our series, and we look forward to having you on that. So with that, let's get started with some questions here. Our first question is ISTA referenced in the ISO standards?
Yeah, this is Jennifer. I'll take that question. So it is referenced in the ISO standards, and it is recognized. They do recognize the ASTM as well. They do prefer that you do the 3A testing.
All right, thank you, Jennifer. Wendy, do you have anything you want to add to that, or?
Nope, I don't have anything to add to that, Chris.
Okay.
Sorry.
All right, we'll move on to another question here. For a device that is soft and flexible with no sharp edges, can actual shipping be used instead of lab-based simulator testing?
I'll take that one, Chris. This is Wendy. The use of lab-based testing is really required. It doesn't really matter what the product or the device is, because even though we're evaluating the interaction of the product with the package, you're still required to have evidence to do that test. So the answer is yes, you would still be required to do lab-based testing. The only time that I would look at outside of lab-based testing is if I'm doing my feasibility, and that would be more in the line of just in the very beginning stages. I would ship it around maybe using UPS and see how my prototyping did, but for actual validation, definitely do a lab-based ship test.
All right, thank you, Wendy. Another question here asks, if Nelson performs microbial barrier testing for a customer using the 1608 method, how would the customer know that their material provides an acceptable microbial barrier?
That's a great question. This is Wendy again. So a lot of times the sterile barrier supplier of preformed systems, such as pouches or tray material, will have already done microbial testing, and a lot of times we're doing a comparison to the what the original certification is from the manufacturer. Now, that being said, if it doesn't exist, I would look at doing some evaluation of the material before and setting up our own spec. But the testing has been around since the 80s, and it's easy to know based on what your values are if there are any issues. For example, a paper pouch that's uncoated is going to have an LRV of probably less than 2, whereas Tyvek is very well tested and will frequently come up with values 4.2 or higher, depending on the method of sterilization that you're using and the Tyvek materials that you're using.
All right, thank you, Wendy. We'll move on to another question here. Is visual inspection of the outer pouch enough to meet the intent of a tamper evidence seal?
Again, a great question. Visual inspection is not really designed to prove tamper evidence. It's more in alignment with ensuring that the seals that you are making are repetitive. For example, the actual document only calls out specifically that you're looking for channels through the seal. So even though that would be a sterile barrier breach, it does not provide any information about tamper evidence. And I believe there's a completely different document that addresses that.
All right, thank you, Wendy. Another question here for you asks, should shelf life testing be repeated after moving sterilization from one cobalt 60 gamma facility to another cobalt 60 gamma facility?
I don't think you would need to repeat, this is Jennifer, I don't think you would need to repeat the shelf life component, but you would need to do a validation of the other facility to make sure that the gamma sterilization is effective. And since you're just changing facilities, the validation requirements would be much lower than your initial validation was to validate your initial facility.
All right, thank you, Jennifer. We've got another question here that asks, so is microbial ingress a new test requirement?
No, microbial ingress has been around for a very long time. Many of these test methods have been around for decades. Some of them are newer, but the component has been around for a long time and has, in fact, the physical testing, I think, is going to be a newer requirement than the microbial. So the microbial was sort of the way we did things in the past, and then they've added the other physical testing in more recently.
All right, thank you, Jennifer. Another question here that asks, what are the biocomp requirements for packaging?
That's a great question. This is Wendy. The ASTM F2475 is currently under ballot. The answer is that there is a table in that ASTM that identifies exactly what the requirements are. At a minimum, you're going to want to look at doing an MEM or a cytotox study. It does have additional requirements from there, but determining where that responsibility lies for those tests is determined between the supplier of the packaging and the medical device user. The important part to point out, and I'm sure that they discussed this significantly yesterday, is that packaging is considered an accessory of the medical device, and so by doing an evaluation of the medical device, you're capturing that aspect.
All right, thank you, Wendy. What standards are applicable and what testing is required for non-sterile packaging?
I'll take that one, Chris. Non-sterile packaging is not regulated by ISO 11607. This one comes into determining what testing will meet the needs to demonstrate what you're looking for. So if you are looking to just show that your non-sterile package can make it to the end user, maybe you would want to consider doing a distribution test and then a verification of the effectiveness of those hazards by evaluating it using maybe dye migration or seal strength. But again, there are no requirements. It's just what do you want to do to prove that your packaging will get your product there safely.
All right, thank you, Wendy. We have another question here that asks, what is ASTM F1608? What are the requirements? Or I should say, when is ASTM F1608 required? My apologies.
Oh, no worries. So it falls into the same category as like strength and integrity. We demonstrate the microbial barrier requirement, and it's not specifically ASTM F1608, just to be clear, because if you have non-porous pouch, then that methodology would not be appropriate because it's only for porous materials. The microbial barrier property test is usually done at a baseline and then the use by date. If you're doing accelerated aging, it would be at the end points. And if you're doing just real-time aging, it would be at the real-time point.
All right, thank you, Wendy. Another question here for you that asks, how accurate have you found your bubble testing to be? We have found issues with accuracy as small pinhole-sized breaches in the barrier may not cause air bubbles to come out due to folds in the material.
Yeah, that's an interesting one. If you look at the bubble test standard, you'll see that they're only claiming, based on the current round robin, that they have about an 80% detection rate of a 250 micron defect. So if you're using a smaller defect than 250 micron, you're going to get less detection of that. And there are also some other problems with the testing. Most of it has to do with the quality of the defects you make. As you're puncturing the package materials, if you're doing a, well, you're basically not cutting a hole. You're kind of pushing a flap, and so that flap can reseal and close, and if you don't have a nice clean opening, then your effective hole size becomes a lot smaller. So now instead of having what you thought was a 250 micron defect, you have a smaller defect, and therefore you're not going to detect it as easily.
All right, thank you, Jennifer. We have another question here that asks, how does pouch burst testing compare with peel testing? Is it preferred?
The burst testing is a whole package test, and the whole package would be inflated, and then we would get a burst pressure. The seal peel testing is a coupon test, so 1 inch of the seal is tested. They're both acceptable methods. The burst test does not correlate to seal peel testing because the burst test is dependent on package size and materials, and the seal test, it would be a much more uniform test because since you're cutting a 1 inch coupon, now you can compare that 1 inch coupon from a small pouch to a large pouch and get an effective comparison. But either test will work to demonstrate your strength properties. It's just a matter of personal preference, and there may be some other considerations based on your package type that would ask you to choose one method over another.
All right, thank you, Jennifer. Another question here asks, how does someone select the right distribution cycle for ship testing?
That is also another very good question. Selecting the right distribution cycle can be a little difficult. We do have a blog currently on our website with a little more information on that, but basically you would need to go and see what kind of package you were using. So in my example, most packages are less than 150 pounds, and they are shipped single parcel using the truck and air approach. So that's usually the cycle that most packages will fall into. But if you're doing any of those other options like pallet testing or such, then you need to go through the very long list and figure out which one specifically matches your package.
All right, thank you, Jennifer. It looks like we have time for possibly 1 or 2 more questions here, so we're going to try and sneak them in really quickly. How does packaging validation sample size come together with, I guess it's SAL 10 to the -6th?
This is Wendy. I'm going to take that one. Sample size packaging validations do not correspond with the SAL of 10 to the -6. 10 to the -6 is specifically driven around establishing your sterilization validation and achieving that log reduction value to prove that the product that you're getting is making it to the field in a sterile state, and it actually goes into way more than just what I'm saying today. The packaging validation sample size from our approach that we've been really successful is definitely driven around evaluating the risk to the patient. What happens if they get to the field and there's a barrier breach? What types of quality controls do you have in place at your facility? It's more of a risk management approach rather than a log reduction approach.
All right, thank you, Wendy. We're going to sneak one last question in here, and the question here is dye penetration testing still an acceptable method, or is bubble emission testing replacing it?
No, they're both acceptable methods. The dye one is a seal method, so you're just looking at for channels in the seal, whereas the bubble one, you're looking at the whole package. But just like the difference between seal peel testing and burst testing, they're both acceptable methods. It's just up to you to decide which one you would want to use to show your integrity.
All right, well, thank you, ladies, for a great Q&A session and a great presentation. That is all the time that we have for questions today. Once again, if we did not get to your individual question today, someone will get back to you after the program is over, and within the next 24 hours, you will receive a personalized follow-up email with details and a link to today's presentation on demand. Please feel free to invite your colleagues and peers who may not have been available to listen to today's event. This webinar is copyright 2019 by Informa Markets. The presentation materials are owned by or copyright by Nelson Laboratories, and the individual speakers are solely responsible for their content and opinions. I'm Chris Keach. Once again, we'd like to thank you for attending today's course, and we hope you'll join us tomorrow.